Throughout my career, I've done research for the U.S. Department of Transportation, the United States Department of Defense, motor vehicle manufacturers, and child restraint manufacturers in the U.S. This is the first I've really seen of any concerted effort to develop smarter wheelchairs that can mitigate the injury altogether and completely obviate my entire role here.
We're looking at impacts on the user when there's a crash. So we're going to run this wheelchair into the wall.
It was a direct impact to the kneecap, driving loads through the femur to the pelvis. And it's very similar to what happens in a car crash in a frontal impact, where the knees go into the knee bolster or the portion of the dash that's below the instruments on the driver's side. And the forces that we observed in the wheelchair crash actually exceeded the limits that are allowed by federal law for a car in a car crash.
On this test, we're going to run off of a 6-inch step.
So the level of head injury that we saw in the lateral impact corresponds to what we would call an AIS-2 injury, which is a significant head injury that could range from concussion without loss of consciousness to loss of consciousness up to 6 hours. The criteria that we use for crash test dummies and things like that are based upon healthy occupants. Obviously, the wheelchair occupant has a compromised biomechanical tolerance. For example, the rotational head injury tolerances are based largely upon U.S. football players who have a concussion tolerance that's at the high end of what healthy humans have.
After looking at a lot of the results, particularly the tip over of the front wheel drive, there was a greater than 50% chance of severe head trauma from those accidents.